In today's digital world, information travels at the speed of light, literally. This incredible feat is made possible by optical cables, the backbone of modern communication networks. Unlike traditional copper wires that transmit data through electrical signals, optical cables utilize light pulses to carry information over long distances at astonishing speeds. This revolutionary technology has transformed the way we communicate, enabling lightning-fast internet speeds, crystal-clear phone calls, and seamless data transfer. But how do these thin strands of glass transmit vast amounts of information using light? Let's delve into the fascinating world of optical fiber and explore its inner workings.
An optical cable might seem delicate, but it's a marvel of engineering designed for durability and efficiency. These cables are essential in modern communication, transmitting data at the speed of light across vast distances. At its core lies the optical fiber, a hair-thin strand of ultra-pure glass or plastic. This core is the heart of the cable, where the magic of data transmission happens. This fiber is surrounded by several protective layers that shield it from damage and environmental factors. Each layer plays a crucial role in maintaining the integrity and performance of the cable. The first layer, called the cladding, has a slightly different optical property than the core. This cladding is essential for guiding the light through the core without significant loss. This difference in refractive index causes the light to reflect back into the core as it travels, a phenomenon known as total internal reflection. This principle ensures that the light signals can travel long distances with minimal loss. Surrounding the cladding is a buffer layer that provides cushioning and further protection. This layer absorbs shocks and prevents physical damage to the delicate fiber inside. Finally, a strong outer jacket encases the entire cable, safeguarding it from moisture, abrasion, and other external elements. This outer layer is often made of tough materials like polyethylene or PVC, ensuring the cable can withstand harsh conditions and last for years.
The magic of optical fiber lies in its remarkable ability to guide light through its core, even when bent or curved. This unique property is what makes optical fiber so essential in modern communication systems. As a light pulse enters one end of the fiber, it strikes the interface between the core and cladding at a specific angle. This angle is crucial because it determines how the light will behave as it travels through the fiber. Due to the difference in refractive indices between the core and the cladding, the light undergoes a phenomenon known as total internal reflection. This means the light is effectively bounced back into the core, preventing it from escaping. This process of total internal reflection repeats itself countless times as the light travels through the fiber. Each reflection keeps the light trapped within the core, allowing it to travel long distances without significant loss. The light zigzags its way down the fiber, guided by the principle of total internal reflection. This zigzagging path ensures that the light remains within the core until it reaches the other end of the fiber. This efficient method of light propagation minimizes signal loss and allows for data transmission over long distances with minimal attenuation. The ability to transmit data with such high efficiency is what makes optical fibers the backbone of our global communication networks, enabling everything from internet browsing to high-definition video streaming.
Before transmission, data is encoded into light signals using a device called a transmitter. The transmitter converts digital information, represented by a series of zeros and ones, into pulses of light. These light pulses are then launched into the optical fiber. A pulse of light represents a binary 1, while the absence of light represents a binary 0. At the receiving end, an optical receiver detects these light pulses and converts them back into electrical signals. These electrical signals are then decoded to retrieve the original digital information. This elegant system allows for the transmission of vast amounts of data at incredible speeds, limited only by the speed of light itself.
Section 5. Optical fiber communication, a high-speed highway. Imagine a highway where data packets are cars traveling at the speed of light. This is essentially how data transfer through optical fiber works. Each light pulse acts as a carrier for a piece of information, speeding through the fiber optic highway with minimal resistance. At the receiving end, these light pulses are captured and decoded, reconstructing the original data with remarkable accuracy. This high-speed, low-latency communication is what makes optical fiber ideal for applications that demand real-time responsiveness, such as video conferencing, online gaming, and financial transactions.
Section 6. Out with the old, in with the new fiber versus copper. In this section, we will explore the key differences between traditional copper cables and modern optical fiber technology, and why the latter is becoming the preferred choice for data transmission. Traditional copper cables transmit data using electrical signals, which are susceptible to interference and signal degradation over distance. This means that as the distance increases, the quality of the signal decreases, leading to potential data loss and slower transmission speeds. Optical fiber, on the other hand, transmits data using light, which is immune to electromagnetic interference and experiences significantly lower signal loss. This makes it a more reliable medium for transmitting data, especially in environments with high levels of electromagnetic interference. This fundamental difference translates to several advantages for optical fiber. Not only does it provide a more stable and consistent connection, but it also supports higher data transfer rates. Fiber optic cables offer significantly higher bandwidth, meaning they can carry much more data than copper cables of the same size. This is particularly important in today's data-driven world, where the demand for high-speed internet and large data transfers is constantly increasing. They also allow for data transmission over longer distances without the need for signal boosting. This reduces the need for additional infrastructure and maintenance, making it a more cost-effective solution in the long run. Moreover, fiber optic cables are lighter, thinner, and more durable than copper cables, making them easier to install and maintain. Their durability means they are less likely to be damaged during installation or by environmental factors, ensuring a longer lifespan and more reliable performance.
Section 7. Confidentiality in glass. How secure is fiber optic data? One of the most significant advantages of optical fiber is its inherent security. Unlike electrical signals in copper cables, which can be easily intercepted and tapped, light signals in optical fiber are extremely difficult to tap without detection. Any attempt to access the light signal within the fiber would cause a noticeable drop in signal strength, alerting network administrators to a potential breach. This inherent security feature makes optical fiber the preferred choice for transmitting sensitive data, such as financial transactions, medical records, and government communications.
Section 8. Fiber in action, real-world applications. The impact of optical fiber on our daily lives is profound. From the high-speed internet we rely on to the streaming services we enjoy, optical fiber is the invisible backbone that powers our digital world. Telecommunication companies use vast networks of optical fiber to provide high-speed internet, telephone and television services to homes and businesses. Data centers, which house the servers and networking equipment that power the internet, rely heavily on optical fiber for high-speed data transfer and interconnection. Moreover, industries such as healthcare, finance and manufacturing utilize optical fiber for secure data transmission, remote monitoring and industrial automation.
Section 9. The future of light. Advancements and potential. The field of optical fiber is constantly evolving, with ongoing research and development pushing the boundaries of speed, capacity, and functionality. Scientists are exploring new materials and fabrication techniques to create even thinner, more flexible, and durable optical fibers. Advances in optical amplification and signal processing are further extending the reach and capacity of fiber optic networks. Researchers are also investigating new applications for optical fiber, such as sensing, imaging, and even quantum communication. These advancements promise to revolutionize various fields, from medical diagnostics to environmental monitoring and beyond.
Section 10. Conclusion: the power of light in the information age. Optical fiber has revolutionized the way we communicate, enabling the high-speed, high-capacity data transfer that underpins our digital world. Its remarkable properties, such as high bandwidth, low latency, and inherent security, make it the ideal medium for transmitting vast amounts of information over long distances. As technology continues to advance, optical fiber will undoubtedly play an even more crucial role in shaping the future of communication, connecting people, devices, and information in ways we can only imagine. From the internet we browse to the entertainment we stream, the power of light, harnessed through optical fiber, illuminates the path toward a more connected and technologically advanced future.